Welcome to the CosmoX channel. Right at this very second, while you're listening to me, a ray of light from the star you looked at yesterday started its journey back when our ancestors had no idea what fire was. Stop for a moment. This very photon, a microscopic particle of light that touched your eye, has been traveling through the darkness of space longer than the entire history of humanity has existed. It witnessed the birth and fall of civilizations. When Egypt was building pyramids, it was flying. When the Roman Empire turned to dust, it continued. When we invented the printing press, electricity, smartphones, it didn't stop. And only now, precisely in these seconds, has it completed its journey entering your eye. And you didn't even notice. A light year isn't just a number from a textbook. It's a sentence. It's a prison of cosmic proportions from which humanity will never escape. We call it a distance, but in reality, it's time frozen in space. And today you'll learn why your brain is physically incapable of grasping these dimensions. I'll tell you about 3 things that will make you look at the night sky in a completely new way. First, why is the closest star to us so far away that even humanity's fastest spacecraft would take more than 70,000 years to reach it? Second, why is the universe expanding faster than the speed of light, and why are 94% of all galaxies lost to us forever? Third, why does the very concept of distance in space lose all meaning in our usual understanding? You'll learn something that will change your view of the stars forever. Something that makes it hard to fall asleep afterward. Something that shows how insignificant and helpless we are in the face of infinity. If the mysteries of space fascinate you, subscribe. The journey begins right now. Remember school lessons about space? The teacher showed a picture of the solar system. Planets neatly lined up in a row, like beads on a string. From Earth to Mars, a couple of centimeters on the drawing, to Jupiter, a hand's width, to Neptune, about half a meter. Everything looked so cozy, so understandable, so close. We were told that space is humanity's next frontier, that we'll definitely fly to Mars, then further, and from there it's just a stone's throw to the stars. Science fiction painted ships jumping between galaxies as if between cities. We believed that one day humanity would spread across the universe, just as it once spread across the planet. It was a beautiful fairy tale. But reality is completely different. And it's much, much darker. Let's start with the basics. 1 light year is the distance that light travels in a year. Sounds harmless, right? But light rushes at a speed of 299,792 kilometers, not per hour, not per minute, per second. In 1 second, a beam of light circles the Earth 7.5 times. In 1 second, now multiply that speed by the number of seconds in a year. You get approximately 9.5 trillion kilometers. That's 1 light year. Just one. And now imagine, the nearest star, Proxima Centauri, is 4.2 light-years away. That's almost 40 trillion kilometers. 40 trillion. Say this number out loud. 40 trillion kilometers. Your brain just heard these words and simply froze. It's physically incapable of comprehending this. Evolution didn't prepare us for such numbers at all. Our ancestors never encountered such scales. What is the human mind tuned to? At most, to estimate the distance to that cliff. Or to the horizon line. Well, 50 kilometers, maybe 100. That's the limit of what we feel intuitively. Everything else? Empty numbers. Abstraction. Symbols without real meaning for our consciousness. Okay, let me explain it differently. Imagine, you board a regular passenger airplane. Boeing or Airbus, doesn't matter. It accelerates to 900 kilometers per hour. And you fly to the nearest star. Guess how long this flight would last? 5 million years. Million years. Without landings, without stops for coffee. Just flying through absolute nothingness. And you know what? When you're just taking off, there aren't even humans on Earth yet. At all. Only Australopithecines who are just learning to walk on 2 legs. And when you finally arrive, humanity has either long died out, or transformed into something completely non-human, or colonized the galaxy. If, of course, it found a way to overcome these insane distances. But you won't find out, because you're still in flight. And this, mind you, is the closest star, the one that's literally around the corner by cosmic standards. And now Andromeda, our neighbor, the nearest large galaxy, 2.5 million light-years, 2.5 million times 9 trillion kilometers. This number is so enormous that it loses all meaning. It exists only as a mathematical game, nothing more. But here's what's truly frightening. The universe is expanding. Right now. And faster than you can possibly imagine. Edwin Hubble proved this almost a century ago. Galaxies are running away. And the farther the galaxy, the faster it recedes from us. At a certain distance, approximately 14 billion light-years, the speed of this expansion exceeds the speed of light. You heard that right? Faster than light. This doesn't break the theory of relativity, because nothing moves through space faster than light. But space itself? It can expand at any speed. And it's expanding right now while you're listening to this. Billions of galaxies are disappearing beyond the cosmic horizon. Forever. Irretrievably. Their light will never reach us because the space between us is growing faster than that light can cross it. We're trapped in a tiny bubble of the observable universe. And this bubble becomes more lonely with each passing second. They don't tell you about this in school, do they? This part of space is preferred to be kept quiet, because it's too discouraging, too overwhelming, too honest. But you're here precisely for this, for the truth, however cruel it may be. Let's go deeper. Light is the fastest thing in the universe. Nothing can move faster, and this isn't a technical limitation that we'll someday bypass. This is a fundamental law of nature. You know what's truly frightening? The universe simply won't let us move faster than light. This isn't a technological problem. It's a fundamental law woven into the very fabric of existence. Einstein revealed a terrible truth. Equals mc squared. And here's where the nightmare begins. When you accelerate an object, each additional kilometer per hour requires more and more energy. And approaching the light barrier? Energy costs skyrocket to absurd levels. Want numbers? Here you go. To accelerate just 1 gram, the weight of a paperclip, to the speed of light requires all the energy that humanity has produced over millennia. All the oil on the planet? Not enough. All the coal, gas, uranium? A drop in the ocean. Even if you gathered everything the sun has released over several millennia, it wouldn't be enough for 1 gram. Now imagine a ship. Hundreds of tons of metal, people, supplies. See the scale of the catastrophe? Okay, let's say a miracle happened. We somehow impossibly accelerated to 10% of light speed. This already borders on magic. Flight to the nearest star? More than 40 years. One way, the same amount back. Your crew will age and die en route. Message home? Wait 8 years for a response. And this is, to the neighbor around the corner by cosmic standards. And now feel the real scale. The Milky Way stretches 100,000 light-years. Think about it, 100,000 years, that's longer than our species has existed. A beam of light starting from one edge of the galaxy will reach the other edge in a time longer than all of human history. And it will be traveling at the maximum speed possible in the universe. But here's what will blow your mind. Every time you look at the starry sky, you are a time machine. Right now. The moon? You see it with a 1-second delay. The sun? An 8-minute past. If it went out right this second, we'd only learn about the catastrophe 8 minutes later. Proxima Centauri is shining at you from 4 years ago. Maybe it's already gone. Maybe it exploded the day before yesterday. But you won't know. You're looking at a ghost. Andromeda? 2.5 million years ago. When its light set out on its journey, ape-like ancestors roamed the Earth who didn't even suspect that these dots above were entire universes separated by an incomprehensible abyss. And there are galaxies whose light has been traveling to us for 13 billion years. We see their childhood, the moment of birth after the Big Bang. Now they're completely different, or dead, or absorbed by neighbors. But their youth is still on its way, breaking through the expanding void. This isn't a beautiful metaphor. This is the concrete physics of our reality. So yes, every time you look at the stars, you're traveling into the past. Without any time machines. Every time you raise your eyes to the night sky, you become a witness to something incredible. You literally travel through time. Only there's one cruel detail: this journey works exclusively in reverse. The future of space is closed to you forever. You're doomed to see only what has already happened. And now imagine the most terrifying thing. Somewhere out there, in this infinity, a star is burning. It shines, lives its life, and it knows absolutely nothing about your existence. For it, you simply haven't been born, because the light from the sun hasn't yet delivered the news of humanity to it. Or maybe it has, but showed it Earth from the age of dinosaurs. A planet without a single city, without technology, without intelligence. Just a wet ball with bacteria and primitive creatures. Do you understand what the real tragedy of our loneliness is? It's not that we're the only ones in all this infinity. Perhaps the universe is teeming with intelligent civilizations. But such monstrous abysses of space lie between us that a meeting becomes practically impossible. Here's a thought experiment for you. Let's say in Andromeda, our neighboring galaxy, there exists an advanced civilization. At this very second, they're pointing their telescopes at the Milky Way. And what do they see through their lenses? A picture from 2 million years ago. Earth in the era of Australopithecines. No megacities, no lights of civilization, not a single radio signal. Complete silence. To them, we simply don't exist. Now for the most insane part. Let's suppose they decide to send us a greeting right now. How long will it take to receive it? 2.5 million years. In that time, the entire evolution of humanity will have changed on Earth. We'll either disappear completely or transform into something so different that our descendants won't recognize us as their ancestors. And if they send a response back? Add another 2.5 million years. Total, 5 million years for the simplest dialogue. 2 sentences in 5 million years. You can't even call that a conversation. It's like throwing a note into the ocean and hoping that thousands of generations later, someone will find it on another continent. But listen to what happened when humanity first grasped these scales. Let's go back to the 19th century. Before that moment, people thought the stars hung relatively close by. Well, a few million kilometers, at most, tens of millions. Yes, the numbers were frightening, but still somehow comprehensible to the brain. And then came the breakthrough moment. Friedrich Bessel made his calculations for the star 61 Cygni. The result turned out to be shocking: 100 trillion kilometers. Try to comprehend that number. 100 trillion. It simply tears consciousness apart. It's impossible to work with such numbers. You can't even write them down properly. What do astronomers do? They invent the light year. But here's the thing. It's not to make it easier for us to understand space. Quite the opposite. It's simply a technical device to somehow reduce these insane numbers to a pronounceable size. The light year is just a mathematician's trick, an attempt to package the incomprehensible into something that can at least be spoken aloud. But you know what happens? This trick turns against us. It creates a dangerous illusion of proximity. You hear the phrase 4 light years, and what do you feel? It sounds as mundane as 4 kilometers to a neighboring town. A small number. Something achievable, right? Your brain deceives you. It transforms an astronomical nightmare into something familiar. And the reality? 4 light years is 40 trillion kilometers. Read that again. 40 trillion. You won't be able to walk that distance. You won't be able to drive it. You won't fly it in any ship we've built or will build in the coming centuries. This distance destroys hope. It buries all fantasies about interstellar travel. It turns us into prisoners of the solar system. And no beautiful words about light years will change this merciless truth. But wait, what I've just told you, that's still just flowers. The real horror lies elsewhere. We are physically incapable of comprehending the scale of our prison. Think about this. Your brain was formed over millions of years of evolution. For what purpose? To survive in specific conditions. Track prey. Run from a saber-toothed tiger. Build shelter from rain. Raise children who will continue the lineage. What distances mattered to your ancestors? A few kilometers of savanna. At best, a couple hundred kilometers during seasonal migrations. That's the entire scale. Your brain is designed for the dimensions of the African plains, not for the expanses of galaxies. Try right now to imagine a light year. What happens? Your consciousness simply capitulates. It gives you some kind of blurred abstraction. Oh, it's far. Very, very far. And that's it. Curtain. No real sensations, no deep understanding, no internal tremor from comprehending the scale. It's like trying to feel 1,000,000,000,000 rubles. You sort of understand that it's a pile of money. But can you truly sense the difference between 1,000,000,000,000 and 1,000,000,000? Of course not. For your perception, both these numbers merge into one category, fantastically much. Period. It's the same story with space. 1 light year, 1,000 light years, 10 million light years for our perception, all this falls into one basket labeled prohibitively far. We don't feel the difference. We cannot internally sense that 10 million is 10 million times farther than 1. For us, these are just numbers on paper. And here, in this chasm between knowledge and sensation, hides the bitterest irony of human cognition. We've accomplished the incredible. We've discovered the universe in all its grandeur, measured it to the last parsec, cataloged billions of galaxies, counted trillions of stars, detected countless planets. But to truly understand what we've discovered, that's beyond our capabilities. We're like insects that stumbled upon a geographical map. Yes, we distinguish the lines of continents. But what is an ocean thousands of kilometers wide? That's beyond our comprehension. We see Australia on the map, but how does an ant get there? The information exists, but it's completely useless. The universe is spread open before our telescopes, but it's tightly closed to our ships. And you know what's most cruel? Perhaps, just perhaps, it's forever. This thought is unbearable to accept. You immediately want to object. Come on, humanity will surely figure something out. We've always found a way. And it's true. History is on our side. We were told that people would never rise into the air. We built airplanes. We were told that the atom was indivisible. We split it. We were told that the moon was unreachable. We left footprints on it. So why not bypass this damn speed of light limit? But you see, what's the fundamental difference? This isn't a puzzle for engineers. This isn't a question of budget or technological progress. This is a wall built into the very fabric of reality. The speed of light isn't a barrier that can be broken through with a more powerful engine. It's the very architecture of space-time. It's not an obstacle. It's the rule of the game. Yes, there are theoretical loopholes. The Alcubierre drive, which folds space around a ship. Wormholes connecting distant points of the universe. But here's the catch. All these concepts require things that probably don't exist in nature. Negative energy. Exotic matter with impossible properties. These aren't technologies of the near future. These aren't even technologies of the next 10,000 years. This is something so extreme that we don't even know if it's possible even in theory. And that means we're stuck here, on a tiny blue dot flying around an unremarkable yellow star, lost in one of the spiral arms of an ordinary galaxy among hundreds of billions of other galaxies. And between us and everything else, an abyss. An abyss measured in light years. An abyss that our mind cannot encompass. An abyss that, quite probably, will remain unconquered until the last day of our species' existence. Let's try to do the impossible. Let's attempt to force our brain not just to calculate, but to really feel these distances. Not abstractly understand, but feel them viscerally. We're building a thought experiment, a scale model of the solar system, where every centimeter matters, where proportions are absolutely precise. So, the sun is an inflatable beach ball 1.5 meters in diameter. Huge, but you can still embrace it with your arms if you try. Are you holding this picture in your imagination? Excellent. Now guess, at what distance from this ball will our Earth be? Maybe 1 meter away? 150 meters. Can you imagine? 1.5 football fields between you and that beach ball. And you know what size the Earth itself will be at this scale? The pea. An ordinary green pea from soup. And the moon? A grain of sand 40 centimeters from that pea. A tiny speck circling around a pea, which itself circles around a ball 150 meters away. Mars will be located at 230 meters. Jupiter, almost a kilometer away, 780 meters to be exact. Saturn will push back to 1.5 kilometers. Uranus will fly off to 3 kilometers. And Neptune will end up almost 5 kilometers from the starting point. That's roughly an hour's walk at a leisurely pace. All of this is just our tiny home, our solar system, our cozy corner. And now the main question that will blow your mind. Where in this model will the nearest star to us be Proxima Centauri? Ready for the answer? 40,000 kilometers. Read that again. 40,000 kilometers from your beach ball. That's the length of Earth's equator. To reach the neighboring star in this model, you'd have to walk around the entire planet in a circle. And this is the closest star, our nearest neighbor, practically next door by cosmic standards. Do you grasp the scale now? Inside the system, distances are measured in hundreds of meters, maximum kilometers. But to the next star, tens of thousands of kilometers. A gap of tens of thousands of times. That's why flights between planets are one story, and flights between stars are a completely different universe of complexity. This isn't just the next stage of development. This is an attempt to jump across a canyon whose width exceeds everything we can even imagine. Yes, we've sent probes to the boundaries of the solar system. Voyager 1, launched in '77, is still hurtling through the darkness. It has already broken beyond the heliopause, the protective cocoon of the solar wind. It has entered interstellar space. In 46 years of its journey, Voyager 1 has flown about 24 billion kilometers. 24 billion kilometers. This is the most distant object ever created by human hands. A monument to our audacity and thirst for knowledge. And here's the question that will destroy all your optimism. What fraction of the journey to Proxima Centauri has it completed? 0.06%. Less than 1,000th in nearly half a century of flight. If we pointed Voyager 1 straight at Proxima, and it's currently flying in a completely different direction, how long would its journey take? More than 70,000 years. 70 millennia. That's 10 times longer than our entire written civilization. That's longer than Homo sapiens has existed in its modern form. Yet Voyager 1 is racing at a speed of 17 kilometers per second. By our human standards, that's insane. A sniper bullet flies at about 1 kilometer per second. Voyager is 17 times faster. But even this cosmic speed is a pathetic mockery in the face of interstellar distances. Even it is catastrophically insufficient to cross the abyss in any reasonable time frame. And here's what truly chills the soul. The space between stars is not just a vacuum. It is absolute, total nothingness. Absolute, all-consuming, boundless nothingness. We on Earth exist in a soup of molecules. Air envelopes us, the atmosphere protects us, particles dart everywhere. Even when scientists create a vacuum in laboratory chambers, the most perfect one possible, there are still billions of molecules swarming in every cubic centimeter. But what about interstellar space? 1 atom per cubic centimeter. Think about that for a second. The area under your fingernail, and in that volume of space there's just one single hydrogen atom floating around. Nothing else. Absolute emptiness. The temperature there hovers around 3 degrees above absolute zero. Minus 270 Celsius. This is such extreme cold that the very word, temperature, loses all meaning. There's simply nothing there to be cold or warm. Only infinite, dead, deafening silence. No sounds, sound has nothing to propagate through. No light, only distant sparks of stars, separated by unimaginable distances. No movement, except for rare atoms drifting through eternity. Now imagine you ended up there. Not in a spacesuit. Just you. A living human being. You would die within seconds. The oxygen in your lungs would boil instantly. Blood would begin evaporating through your skin pores. Your body would freeze into an icy sculpture and set off on an infinite drift through the void. And that icy figure would fly forever. Millennia. Millions of years. Without a single change. Without decomposition, there's nothing there to decompose it. Without witnesses, no one would see it. just a frozen lump of organic matter, lost in an ocean of nothingness between the stars. Interstellar space is the most hostile place in the entire universe. Even black holes or the surfaces of neutron stars don't compare. Even in the cores of gas giants under monstrous pressure, at least something is happening. There's energy there. Processes. Transformation of matter. But in the interstellar void? Nothing. Absolute, eternal, mute nothing. And this nothingness, trillions and trillions of kilometers between each pair of stars. That's why a light year is not just an abstract measure of length. It's a description of emptiness. It's a way of saying, from this point to that point stretches 9.5 trillion kilometers of absolute, total emptiness. Try to imagine this nothingness. Hold this picture in your consciousness. Trillions of kilometers where there is literally nothing. Nothing at all. Not a particle of matter. Not a drop of energy. Not time in the sense we understand it. Only space, existing for itself. Without content. Without meaning. Without purpose. This is what stands between us and the rest of the universe. This is the wall we will probably never breach. And when you truly realize this, not superficially, not intellectually, but somewhere deep in your soul, you begin to understand our real situation. We are not pioneers on the threshold of great discoveries. We are prisoners in a beautiful cage. Our prison cell is the solar system. The prison walls are light years of absolute vacuum. And we have no key to this cell. Perhaps that key doesn't exist in principle. But you know what? Let's not get stuck on this depressing note. Let's dive even deeper, to where the numbers completely blow your mind. Until now we've been discussing distances to neighboring stars. For light years, 40 trillion kilometers. It seemed it couldn't get worse. But our galaxy, the Milky Way, contains between 200 and 400 billion stars. And the diameter of this stellar disk is 100,000 light years. 100,000 light years. If 4 light years turn into 40 trillion kilometers, then 100,000 light years. I won't even voice that number. It loses all meaning. It's so gigantic that it becomes pure abstraction. A set of meaningless symbols on a screen. We're floating somewhere about 26,000 light years from the galactic center. From that monstrous supermassive black hole that keeps this whole carousel of stars from flying apart. Sagittarius A*. That's what astronomers named it. The mass of 4 million of our suns, compressed into a mathematical point. Around it, hundreds of billions of stars circle in an endless cosmic dance. Light from there takes 26,000 years to reach us. Wait, comprehend that number. When photons of light left the center of the galaxy and began their marathon to Earth, the Ice Age reigned here. Our ancestors were hiding in caves from the cold. They had just learned to scratch drawings on cave walls. Just beginning to knock stone against stone, making the first primitive tools. Just groping toward the first glimmers of culture. And these photons, which started in that wild era, are only now, right now, hitting the lenses of our telescopes. What does this mean? We don't see the galaxy in real time. What we observe is a ghost of the past. And different pasts for different sections. Nearby stars show us a picture delayed by years or decades. Distant ones delayed by millennia. What we call our galaxy is actually a patchwork quilt of different eras stitched together by light. This is not a snapshot of a moment. This is a layering of countless moments smeared across 100,000 years. And we ourselves are part of this illusion. For someone on the opposite edge of the galaxy, light from our sun right now is showing Earth from 100,000 years ago. A planet roamed by our evolutionary ancestors, not even suspecting the existence of stars above their heads. If intelligent beings live there and they've aimed their telescopes at our sun, what will they see? Our cities? Our radio signals? Nothing of the sort. They'll see a lifeless rock. A planet without a single sign of civilization. Without the lights of metropolises. Without traces of intelligence. And they'll conclude, there's no one there. And we at this very same time are looking in their direction and seeing their past. Maybe their civilization already collapsed thousands of years ago in a catastrophe. Or maybe Conversely, it soared to such heights that we can't even imagine. We don't know, and we can't find out. Between us yawns an abyss not only of space, but of time. This is one of the most insane features of our universe. Distance and time here are woven into a single fabric. Look far, see the past. No way to see distant objects, as they are now, exists. This concept simply doesn't exist in nature. Physicists will explain to you, the very concept of simultaneity loses meaning on galactic scales. There is no universal now that would be the same for the entire universe. Each point in space has its own personal now. And these nows are not synchronized with each other. This is hard to swallow, right? Our brain is designed to perceive time as something absolute and unified. There's the past, it's behind us. There's the present, it's right now for everyone. There's the future, it's ahead. And this present is the same for everyone. Everywhere, boys. But this is a lie. This is another illusion from those that our brain stamps out for comfortable existence in everyday life. On the scale of the African savanna, where our mind was formed, this illusion works flawlessly. On the scale of the universe, it falls to pieces. So it turns out, we are beings whose brain paints a false picture of reality. We think we understand space and time, but we don't understand them. We've just gotten used to how they behave on those microscopic scales accessible to our perception. A light year is an attempt to describe what lies beyond our illusions. It's an attempt to speak about the universe as it really is, not as it's convenient for us to imagine it. And this reality is absolutely merciless, indifferent to us, so colossal that everything human dissolves in it without a trace. Let's ascend even higher, beyond the galaxy, beyond the boundaries of the Milky Way. We live in the so-called local group of galaxies. This is a gravitationally bound family of approximately 80 galaxies. The Milky Way is our home. Andromeda is our neighbor. Triangulum, plus a whole retinue of dwarf satellite galaxies rotating around the large ones. The diameter of this local group is about 10 million light-years. 10 million. After those 100,000 we talked about, this might seem like just another big number. Well, yes, another zero. So what? But freeze for a moment. A photon of light leaving one edge of the local group right now will reach the opposite edge in 10 million years. 10 million years of continuous flight at a speed of 300,000 kilometers per second. When this ray of light started its journey, humans didn't exist on Earth. Even primates in the modern sense weren't around yet. Dinosaurs? They went extinct 50 million years before that moment, long since became ancient history. Several million years of evolution remained before the appearance of the first hominids. And this light is only now completing its journey. The local group is our cosmic neighborhood, our immediate surroundings. Those galaxies that we, purely theoretically, very, very theoretically, could someday reach, if we invented a way to move faster than light. But even this local group is just a microscopic fragment of a larger structure. The local group is part of the Virgo supercluster, a giant construction of thousands of galaxies spread across 110 million light-years. What? 110 million. But even the Virgo supercluster is just one element of an even more monstrous structure with the name Laniakea. This is a supercluster of superclusters. About 100,000 galaxies. Extent 500 million light-years. 500 million light-years. 500 million years of flight for light at its insane speed. During the time this light travels, life on Earth experiences a series of mass extinctions. Entire classes of living beings appear, flourish, and disappear forever. Continents crawl across the planet's surface. Oceans open and collapse. The planet becomes completely unrecognizable. And the light keeps flying. And flying. And flying. But wait, we haven't reached the finale yet. Laniakea is not the entire universe. Not even close. It's just our local corner in infinity. The observable universe, that part of the cosmos whose light has managed to reach us in the 13.8 billion years of existence of everything, has a diameter of approximately 93 billion light-years. 93 billion. This number is so monstrous that any attempt to visualize it is doomed from the start. Your brain won't cope. My brain capitulates. Not a single human mind is capable of truly comprehending such a scale. Yes, we can write this number on paper. We can say it aloud. We can plug it into mathematical formulas. But feel it? Never. This is one of the cruelest ironies of human intelligence. We are developed enough to discover the universe and measure it, but we are too small to fit it into our consciousness. And here's what will finish you off completely. The observable universe is not the entire universe. It's only the zone we can see. Beyond the event horizon stretches even more space. How much exactly? Nobody knows. Maybe the same amount. Maybe thousands of times more. Or maybe the universe is infinite altogether. We simply don't know. And what's most terrible, we probably never will. Because the universe is expanding. And a huge part of it is already lost to us forever. Remember I mentioned the expansion of space? About how distant galaxies are running away from us faster than the speed of light. This is not a beautiful metaphor. This is harsh physical reality. Approximately 94% of all galaxies in the observable universe are already beyond the so-called cosmological event horizon. Their light will never, do you hear? Never reach us. They're disappearing beyond the edge of the cosmos, taking with them all their stars, all their planets, all the possible civilizations that might have existed there. And you know what? Every second, several more galaxies cross this invisible boundary. Every second, our observable universe shrinks, becomes slightly more desolate, slightly more lonely. In trillions of years, when our sun has long since cooled and gone dark, when all the stars of the Milky Way have burned through their fuel completely, the night sky will be completely empty. All distant galaxies will disappear beyond the horizon. Only the local group will remain, by that time already merged into one giant elliptical galaxy. And if intelligent beings exist in that era, they will raise their eyes to the sky and see nothing, only their own stars, nothing else. They will be certain that the universe is a single solitary galaxy, drifting in an ocean of absolute emptiness. They won't know that once the sky blazed with billions of lights, that countless galaxies sparkled in the darkness, that the universe was young, seething with energy, rapidly expanding. All evidence of the Big Bang will be erased. The cosmic microwave background will stretch to zero intensity, become undetectable. The redshift of distant galaxies will disappear from view. Astronomers of that distant future will look at the empty sky and think that this is all there is, that the universe is eternal and static, that it has always been this way. They will be mistaken, but they will have no way to discover this. And now the most terrifying part. Maybe we're mistaken right now too? Maybe we're also missing something critically important? Something that already slipped beyond the horizon before we appeared? Something that could turn our entire understanding of the cosmos upside down? We look at the sky and think we see the full picture. But we see only what light years allow us to see. Only that whose light has managed to reach us. Everything else is mystery. Eternal. Impenetrable. Inaccessible. And the light year is the unit of measurement of this mystery. The measure of what part of the universe is forever hidden from us by distance and time. Now let's talk about something even stranger and more frightening. About how distance distorts time. And how time transforms into distance. When Einstein created his special theory of relativity, he encountered something mind-boggling. Space and time are not two separate entities. They are one thing. Space-time. A unified fabric of reality. And this fabric behaves completely insanely at high speeds. Imagine this scenario. You're flying on a spaceship at almost the speed of light. Let's say 99% of maximum. You're heading toward a star 10 light years away from Earth. From the perspective of the people who stayed home, your journey will take a little over 10 years. The logic is ironclad, right? 10 light years at near light speed works out to about 10 years of flight. But here's where the madness begins. From your perspective, from the perspective of a passenger on the ship, this journey will take about a year and a half. Not 10. A year and a half. This is not a calculation error. Not a trick. Not an illusion. This is reality. Time inside the moving ship flows more slowly than on stationary Earth. This phenomenon is called relativistic time dilation. And this is not an abstract theoretical concept from a textbook. This is an experimentally proven fact. We've tested this with atomic clocks aboard airplanes. We observe this in the behavior of subatomic particles in accelerators. It works. It's real. And the closer your speed to the speed of light, the stronger the effect. At 99.9% the speed of light, time slows down by approximately 22 times. At 99.99% by 70 times. The closer to the limit, the more radical the slowdown. Theoretically, if you somehow reached exactly the speed of light, time for you would stop absolutely. But you can't do this. No object possessing mass can reach the speed of light. It would require infinite energy. And infinite energy doesn't exist in the universe. But even at achievable speeds, the effects of time dilation give rise to something simultaneously magnificent and tragic. Imagine an astronaut departing for a distant star. For him, this journey will take, let's say, 5 years of subjective time. He will age 5 years. Hair will gray slightly. Muscles will weaken a bit. An ordinary 5-year period of life. Now he returns to Earth and discovers that 50 years have passed here, or 100, or 1,000, depending on the ship's speed and flight distance. Everyone he knew is dead. The world has changed beyond recognition. Technology has made a leap forward by generations. Languages have evolved. Cultures have transformed or disappeared. He returned home. But home no longer exists. There is only an alien future into which he arrived as an archaeological artifact from the past. This is not the plot of a science fiction film. This is physics. This is a direct consequence of the theory of relativity, confirmed by thousands of experiments. And this is yet another facet of what light years actually mean. They separate not only space, they separate time. A journey to distant stars is a journey into the future. And from this future there is no road back to your familiar world. Even if we build a ship capable of accelerating to near-light speed, we won't defeat distance. We'll simply throw ourselves into a distant, unfamiliar future, where everything we loved has long since turned to dust and history. That's why a light year is not just a measure of length. It's a measure of separation, a measure of impossibility, a measure of absolute loneliness. But there's something else. Another aspect of these monstrous distances that's almost never talked about. Energy. To traverse a light year requires energy. And the scale of this energy is so monstrous that it surpasses everything humanity has ever produced in its entire history. Let's calculate with a simple example. Suppose we want to send a tiny probe to Proxima Centauri, very light, weighing only 1 kilogram, and we want it to arrive in a more or less reasonable time, let's say, in 40 years. This means we need to accelerate it to 10% the speed of light. 10% is 30,000 kilometers per second. To give 1 kilogram such speed requires kinetic energy of about 450 trillion joules. How much is that in understandable terms? That's approximately equal to the energy of the explosion of 100 nuclear bombs with a yield of 1 kiloton each. For 1 kilogram of cargo. Now imagine we decided to send a ship with a living crew. A minimal interstellar ship is hundreds of tons of mass. Life support systems. Protection from cosmic radiation. Fuel tanks. Food and water supplies. Scientific equipment. The crew itself with all equipment. The energy required for such a journey exceeds everything humanity has produced in its entire history of existence. All the oil pumped from the depths. All the coal burned in furnaces, all the natural gas, all the nuclear energy ever released in reactors. All of this combined wouldn't cover even a small part of what's necessary for one single interstellar voyage. And wait, this is only acceleration. You still need to brake at the destination. Without braking, the probe will simply rush past the target star at its 30,000 kilometers per second, flash as a bright point and vanish into the abyss on the other side. Braking requires approximately the same energy as acceleration. Either you take fuel for braking with you, which increases the starting mass of the ship, and accordingly, the energy costs for acceleration grow to absurdity. Or you use some external methods. For example, a magnetic sail that brakes against interstellar gas. But remember what the density of this gas is? 1 atom per cubic centimeter. Braking against such emptiness will stretch out over a whole century. And that's in the best case if it works at all. Every path is a dead end. Every solution gives rise to new unsolvable problems. And at the foundation of everything lie these cursed distances. Light years requiring unimaginable energies to overcome. There's a project called Breakthrough Starshot. This is a real scientific initiative funded by Yuri Milner and other wealthy enthusiasts. The idea is this: send thousands of microscopic probes the size of a postage stamp to Proxima Centauri. Each probe is equipped with an ultralight solar sail. And on Earth, a giant laser array with a power of 100 gigawatts is built. This laser illuminates the probe's sails, accelerating them to 20% the speed of light. Sounds like science fiction? Because it practically is science fiction. 100 gigawatts is approximately all the electrical power of a country like Russia. The entire energy-generating potential of a huge state, focused into one laser beam, pushing pieces of foil into interstellar void. And even at such insane scales, the probes will reach their destination only after 20 years of flight, after which they'll need another 4 years to transmit a signal back to Earth at the speed of light. 24 years of waiting for a result. And that's assuming the technology works as intended, that the probes survive the journey, that the infrastructure on Earth remains functional all those years. And we're talking about probes the size of a postage stamp. No possibility of sending people. No possibility of returning back. Just tiny cameras hurtling through absolute nothingness. This is what's required to overcome just the nearest light years. This is the level of technology needed for the most modest, minimalist interstellar journey. And even these technologies don't yet exist in reality. They're in the development stage. They might appear in 10 to 20 years, or they might never appear at all. Because the reality of interstellar distances doesn't just overwhelm the psyche and imagination. It overwhelms physics. It overwhelms engineering. It crushes the very possibility of action. Light years are not an obstacle we'll someday overcome with more advanced technologies. They're a wall that we slam into every time we try to seriously think about space travel. But let's dig even deeper. Let's talk about what all this actually means for us. For humanity. For our place in the universe. We live in an incredible era. Space agencies launch telescopes capable of peering into the farthest corners of the universe. James Webb transmits images of galaxies that formed just a few 100 million years after the Big Bang. We observe how stars are born, how they die in supernova flashes, how galaxies collide in a cosmic ballet of destruction. How black holes devour matter, warping space-time around themselves. We know more about the universe than all previous generations of people combined. And simultaneously we realize with terrifying clarity how powerless we are. This is a strange and cruel paradox. The more we learn, the more obvious our limitations become. The farther we look, the clearer we understand that we'll never get there. Telescopes reveal billions of planets to us. Potentially habitable worlds circling alien stars. Exoplanets in the Goldilocks zone, not too hot, not too cold. Perfect conditions for the emergence of life. And we will never set foot on their surfaces. Never feel the breeze of their wind on our faces. Never see their sunsets with our own eyes. Light years turn these worlds into ghosts, into pictures on a monitor, into data arrays in a supercomputer. They exist but remain unreachable. They're real, but will forever remain an abstraction. And if life exists there, intelligent life, we'll probably never know about it. This brings us to one of the most agonizing questions of modern science. The Fermi paradox. If the universe is so enormous and ancient, if it contains billions of potentially habitable planets, where are all the alien civilizations? Why don't we see any traces of their existence? Why does space maintain absolute silence? There are many hypotheses. Maybe intelligent life is an extremely rare phenomenon. Maybe civilizations are prone to self-destruction. Maybe we're searching in the wrong place or the wrong way. But there's another answer. Simple and frightening to the core. Maybe distance itself is the answer? Maybe every civilization in the universe is imprisoned in its own star system, as in a prison? Maybe no one has ever been able to overcome these cursed light years? Maybe interstellar travel is impossible not due to lack of technology, but fundamentally, at the level of the laws of physics? The universe may be teeming with life. Billions of civilizations scattered across galaxies. And each of them considers itself alone. Each looks at the sky and sees only silent stars. Each dreams of contact that will never happen. Not because they don't exist, but because an abyss yawns between them. That very abyss we measure in light years. This is perhaps the darkest scenario of cosmic loneliness. Not the emptiness of the universe, but its overcrowding. Overcrowding that changes nothing. Billions of islands of life, eternally isolated by an ocean of void. We will never shake hands with an alien being. Won't hear their music. Won't read their literature. Won't learn their history, their philosophy, their art. All of this exists somewhere out there, in infinity. But it's absolutely inaccessible. Cut off by light years, like a wall. And maybe right now they're looking at the sky and seeing our sun? A small yellow dot among millions of other such dots. They don't know that around this little star circles a blue planet. That on this planet live beings building telescopes and dreaming of the stars. Or maybe they do know. Maybe their technologies are advanced enough to make out Earth? But what do they see? They see the past. Earth as it was millions of years ago. Without humans. Without cities. Without civilization. Meanwhile, we point telescopes in their direction. And what do we catch? Photons that left their star when they themselves, perhaps, weren't yet on the map of the universe. Or conversely, their empires already crumbled to dust a million years ago, and we're looking at a ghost of their heyday. We're playing hide and seek through time. Space separates us, that's understandable. But even worse is that entire geological epochs separate us. You know what's truly insidious about a light year? It doesn't just push objects away from each other in space. It scatters civilizations across different temporal layers. Meeting becomes impossible even theoretically, because now, for us and for them are completely different moments in the history of the universe. Maybe we're the only ones in all observable reality? Or maybe there are trillions of us scattered across galaxies? And here's what kills you, for our lives. This makes absolutely no difference. The ending is the same. We are alone. Cosmically, hopelessly, forever alone. No technology can circumvent this. Do you love inspiring speeches about humanity conquering the stars? About our great destiny among the galaxies? About how this is our natural evolutionary path? Sounds beautiful, I won't argue. Only here's the problem. These words live in a world of fantasies, not laws of physics. This is hope disguised as a plan. This is faith that the cosmos is arranged conveniently for us. Spoiler, it's not arranged conveniently for anyone. The universe didn't arrange anything at all. It simply unfolds according to its own rules. Gigantic, indifferent to our dreams, flying apart with each passing second. And the distances in it? This isn't a trial for heroes. This is a sentence. We're tiny. Our biology is laughably fragile. We sit on one rocky ball rotating around an unremarkable star somewhere on the outskirts of an unremarkable galaxy. And the light years around us? These are bars on the windows. Yes, with a stunning view, can't argue with that. A cell with panoramic glazing onto the entire universe. But a cell. Have you ever heard the term cosmic horror? It was launched into circulation by Howard Lovecraft over a century ago. The essence is the feeling when you encounter something so massive and ancient that your brain simply refuses to process it. You feel your complete, total insignificance. Lovecraft had tentacled gods and nightmares from parallel dimensions. But here's the irony of the century. For real cosmic horror, fantasy isn't needed. It's already around you. In each of those cursed light years stretching to the nearest star. In every number astronomers use to describe the universe. We've just developed a protective reflex, not to think about it, to look away. Try to remember, when did you really look at the stars? Not glance up while getting out of the car, but actually look. Turned off the lights, lay down on the ground, let your eyes adapt for 20 minutes. Just observed. For most city dwellers, the sky is an orange glow of streetlights with a couple dozen stubborn bright points breaking through the light pollution. They can't even imagine what the real Milky Way looks like, that glowing river that flows across the entire sky. Ancient people lived under this spectacle every night. Stars were their GPS, calendar, source of stories around the fire. They built megaliths aligned with constellations with engineering precision, memorized the paths of planets among the stars. But one thing they didn't know, what the distance to each of these points meant. For them, stars were windows into the world of gods, souls of dead heroes, holes in the black dome of the celestial sphere, behind which sacred fire burns. We lost that naivety. We discovered the truth. And you know what? Sometimes ignorance was bliss. Because now, when you look up, you understand, every glowing point is a sun. Many have planets. Some of them might have oceans, atmospheres, maybe life, bacteria, or something intelligent. And all of this is forever, absolutely, hopelessly beyond your reach. And then this dizzying spectacle overhead becomes colored with melancholy. Imagine you're standing before museum glass, behind which lie the treasures of the world, but the sign reads, "Look only. Touching forbidden. Forever. You can observe, but touch never. You know what's there, but experience it yourself, impossible. Information without action is exquisite torture. Intellectual hunger that cannot be satisfied. And yet we stubbornly continue. Build ever more powerful telescopes. Launch probes into the void. Dream of the impossible. But what makes us cling to this? Maybe hope is our human superpower? Even when it's irrational. Especially when it's irrational. Or maybe we just haven't fully digested the scale of the problem yet. Somewhere deep down, faith still smolders that someday, somehow we'll outsmart physics. That a loophole is hidden in the equations. That the textbooks are wrong. And you know what? There are scientists who are actually searching for that loophole. Take, for example, the Alcubierre drive. A crazy idea. What if instead of accelerating the ship, we compress space in front of it and stretch it behind? Create a wave in the fabric of reality that will carry the vessel faster than light without formally violating the prohibition? The mathematics allows it. Einstein's equations don't directly say no. But here's the catch. For this you need so-called negative energy. Matter with negative mass. A substance that, as far as we know, simply doesn't exist in nature. It's roughly like saying, of course you can teleport. Just collect 3 kilograms of magical fairy dust that doesn't exist. Theoretically flawless. Practically, a mockery. Or take wormholes, tunnels piercing through space-time, connecting distant points of the universe directly. The same story again, theoretically possible, but require even more exotic matter. Plus they'll most likely collapse instantly. You enter from one side, and collapsing space will smear you before you exit on the other. Quantum teleportation works only for information, not for atoms. And still requires an ordinary communication channel that crawls at the speed of light. Every time the same story. Physicists find a potential crack in the laws. And every time reality slams that door right in front of our noses. As if the universe is deliberately designed to keep us locked up. And perhaps that's exactly how it is. Not in the sense of some malicious creator locking us in a box for entertainment. Just that the laws of nature are such. The rules of the game are written so that interstellar travel for biological beings like us is not provided for. Maybe the universe isn't designed for the spread of life between stars at all? Stars are forges where heavy elements for life are forged. Planets are petri dishes where this life is brewed. But the distances between them are quarantine zones. Each hearth of life develops in isolation. Emerges, evolves, may grow to intelligence or may not. And fades in solitude in its corner of space. Without contact. Without exchange of wisdom or technologies. Grim picture, right? But maybe it's more honest than our Hollywood fantasies about interstellar empires? Although you know what? There's a perverse poetry in this. If we're truly doomed to isolation, not because we're alone in the universe, but because distances turn everyone into prisoners, then everything we create here takes on special weight. Every poem, every melody, every formula scratched on a board, every sculpture, all of this exists only here, on this tiny wet rock. In this fleeting instant of cosmic chronology, there's no backup copy of humanity stored on a cloud server somewhere in the constellation of Orion. No alternative version of our civilization developing in parallel on a planet in the Tau Ceti system. Only us, the sole curators of the museum we've been building for millennia. And this places a burden on us. A monstrous, shoulder-crushing burden. If we disappear through nuclear winter, climate collapse, a pandemic of a new virus, an asteroid we don't notice in time, everything will go dark with us. All of Bach's fugues, all of Shakespeare's sonnets, all philosophy from Confucius to Nietzsche, all discoveries from fire to artificial intelligence. Everything will turn to radioactive ash. And the universe won't even bat an eye. Stars will continue their thermonuclear synthesis. Galaxies will continue their slow dance. Light years will remain light years. And humanity simply won't be. As if we never existed at all. Maybe in a few billion years somewhere another spark of intelligence will flare up? Maybe they too will raise their eyes to the sky and be horrified by the distances? Maybe they'll ask themselves the same questions about meaning and loneliness? But they'll never know about us. Not a line from Dostoevsky. Not a note from Tchaikovsky. Not Einstein's formula. Between us will lie an abyss of time, just as insurmountable as light years of space. This is what cosmic loneliness truly means. Not simply the absence of neighbors behind the wall, but the realization that all your legacy can be erased without a trace. And no one in the universe will notice. Creepy, right? But you know, there's a strange freedom in this too. If there's no external observer to evaluate our achievements, we ourselves decide what matters. If there's no cosmic plan we must fit into, we write our own script. If there's no universal judge to give us a grade, we ourselves set the criteria for success. Light years cut us off from all the rest of the cosmos. But they also gave us complete autonomy. The freedom to create the world we want. Build society by our own rules. Decide what's important and what's trash. This freedom is icy and lonely, but it's all we have. Now let's talk about the ticking clock. Our sun will last another 5 billion years or so. Then it will start to swell, turning into a red giant. It will swallow Mercury, then Venus, and incinerate Earth to a cinder. Everything we ever built will burn in the agony of a dying star. But here's what's really unpleasant: we won't have to wait that long. In just a billion years, the sun will heat up enough to boil Earth's oceans. The atmosphere will escape into space. Life as we know it will become physically impossible. 1 billion years, our absolute deadline. At first glance this sounds generous, right? A billion years is an insane amount of time. Enough for evolution to create new life forms from scratch. Enough for thousands of civilizations to flourish and collapse. But here's the perspective. Life on Earth has existed for almost 4 billion years already. We've already passed 3/4 of the allotted journey. Only a quarter ahead. And intelligent life, you and me, appeared just a few 100,000 years ago. A cosmic instant. A snap of the fingers. Another snap, and we might not be here. If we want to survive the death of our home planet, there's only one way out: leave it. Spread throughout the solar system. Build domes on Mars. Dig cities into asteroids. Create floating stations in Jupiter's clouds. This is damn difficult, but at least theoretically achievable. We don't need to overcome light years, only millions of kilometers within our system. This is a different scale of complexity. But here's the problem. The solar system is also mortal. When our star burns all its hydrogen, it will compress into a white dwarf. A dim fading stub, slowly cooling through eternity. The outer planets will drown in icy darkness. Life there will only be possible with artificial reactors. To guarantee humanity's survival for a billion-year term, there's only one real way out: leap to other stars. Find new suns, new planets, new homes. And here we smash our forehead into that very wall of light years. Maybe in a million years we'll develop interstellar ship technology, slow ones crawling through the void for millennia, arcs with frozen colonists in cryosleep, or with banks of embryos that an artificial womb will grow upon arrival. Generation ships, where the starting crew will die en route, their children will age and die, and only great-grandchildren will see the target star in the porthole. This doesn't contradict physics. This is feasible. It just requires time, resources, and such determination that we don't have anywhere close right now. But suppose we do it. Suppose we scatter colonies across dozens of star systems. We'll still never become a unified civilization. Think about this. A colony 10 light-years from Earth. You send a message, it flies for 10 years. The response flies back another 10. 20 years for the simplest dialogue of 2 phrases. How will you manage such a colony from the center? How will you preserve cultural unity? How can you consider yourself one people with whom normal conversation is impossible? Each stellar colony will inevitably gain independence. Not for political reasons, for physical ones. They'll develop their own dialect. Then a new language. Their own rituals, values, In a couple of generations they'll be as culturally distant from each other as a Tokyo resident is now from an Amazonian aborigine. In 1,000 years, they'll be different species. Biologically, settlement across the galaxy won't create a unified humanity. It will shatter us into thousands of fragments. Isolated islands of civilization, forever cut off from each other by light years. Is this better than complete extinction? Absolutely. Is this a way to preserve at least something of us? Even if these descendants forget where they came from and can't read a single line in their ancestors' language. But this isn't that galactic federation from Star Trek. Not a unified cosmos with instant communication and common laws. This is loneliness to the power of 1,000. Isolation multiplied by the number of colonies. And maybe that's how it should be? Maybe the universe doesn't have to adjust to our fantasies? Doesn't have to be convenient for travelers? Doesn't have to allow us to build empires from edge to edge of the galaxy? The universe simply exists. With its physics, with its scales, with its complete indifference to our ambitions. And we are tiny stubborn beings who seek meaning in the meaningless. Who look at points of light and see not just stars, but potential homes. Who measure impossible distances and still dream of conquering them. This is our greatness, and our tragedy simultaneously. We're smart enough to understand our limitations, but too stubborn to accept them as a final verdict. Or maybe true wisdom is precisely the refusal to accept. This is the willingness to try, even when mathematics is against you. This is the desire to reach for the unreachable, knowing that failure is practically guaranteed. We launched the Voyagers toward the stars, fully understanding they'll never reach them. We launch telescopes farther and farther to make out planets our foot will never step on. We catch radio waves hoping to hear civilizations with which dialogue may be physically impossible. Madness, agreed? But this is the quintessence of humanity. We're those very beings who built Gothic cathedrals for centuries, perfectly understanding that only grandchildren and great-grandchildren would complete them. Who write volumes for people not yet born. Who plant oak trees knowing others will rest in their shade. Maybe interstellar travel is just the next project in this series? An investment in a future we won't witness. A message to descendants across the abyss of time. And even if we never break through the barrier of light years, even if we remain prisoners of one star system until the end, we've still achieved something colossal. We've proven that intelligence can emerge in this icy universe. That atoms are capable of assembling into a configuration that asks questions about meaning. That matter can become aware of itself. This is a miracle, regardless of how many light years surround us from all sides. We are the universe that turned around to look at itself in the mirror, that measures itself, that simultaneously marvels and is horrified by what it sees. And no distances can take this away from us. But let's return to the beginning, to those glowing points overhead, to the stars that are so distant and so beautiful simultaneously. Next time you find yourself under the night sky, and I really hope you'll make time for this, try to hold in your consciousness everything we've discussed. Every glowing point up there is a sun. Around most of them circle planets. Some of these planets resemble Earth, oceans, atmosphere, suitable temperature. On some, life may well exist. And between you and them, light years. Trillions of kilometers of absolute emptiness. Millennia of journey even for the fastest phenomenon in the universe, light. You're looking into the past of these worlds. You're catching photons that began their journey when you didn't exist. When, perhaps, humanity didn't yet exist. And yet this light overcame the abyss, crossed the void, and touched the retina of your eye. Doesn't this border on magic? A connection through space-time. A bridge of light particles stretched between you and distant worlds. You can't get there, but you can see, can know of their existence, can feel this fragile connection. And you know what? Maybe that's enough. We've traveled from the first shocking realization of the scale of a light year to deep philosophical questions about our place in the cosmos. We've discussed distances that the mind cannot grasp, time that warps at relativistic speeds, the void between stars that's more terrifying than any black hole, theoretical possibilities and practical impossibilities of interstellar flight. Now let's put all the pieces of the mosaic together. Let's look at the full picture. What does all this mean for us? For you? For me? For every person who has ever raised their eyes to the stars? We live on a speck of dust. This is not a beautiful exaggeration, not a poetic hyperbole. This is a literal, precise description of our position. Earth is a microscopic rocky ball rotating around an unremarkable yellow star of medium size. This star is one of 200 to 400 billion in the Milky Way. The Milky Way is one of trillions of galaxies in the observable universe. And the observable universe is probably just an infinitesimally small fraction of all that really exists. It's impossible to overstate the scale of our cosmic insignificance. We're so microscopically small that it simply doesn't fit in the head. And simultaneously, we realize this. We understand our position. We're capable of measuring the distance to galaxies while being to them in the same ratio as an atom to a planet. We can describe the life cycle of stars, although our existence isn't even an instant by cosmic standards. It's less than a snap of the fingers. This is the entire paradox of human existence. We are the most insignificant creatures in the universe capable of realizing their own insignificance. And it's precisely this realization that transforms us into something extraordinary. No star knows it's a star. No galaxy understands its spiral structure. No black hole realizes it devours light. The universe is blind to itself. Except for those rare regions where intelligence emerged. We are the eyes of the cosmos. It's self-awareness. Its only way to know it even exists. Does this make us important in some universal sense? The cosmos doesn't care. If we disappear tomorrow, the universe won't even blink. Stars will continue to burn. Galaxies will continue their gravitational dance. Everything will go on as it has for billions of years before the first human raised their eyes to the sky. But this makes us unique. At least here. At least now. At least as far as we know. And light years? They cut us off from everything else. Erect a barrier we may never destroy. But they also create something else. Space for our existence. An arena on which the drama of our history unfolds. Think for a second. What if stars were closer? What if the universe were more compact? Everything would be completely different. Other civilizations could have landed on Earth millions of years ago. Or we could have reached their systems. The history of intelligent life would have turned into a chronicle of contacts, conflicts, exchange of technologies. But distances gifted us isolation. And in this quarantine we developed in our own unique way, forged our own culture, built civilization without hints from outside, without ready-made solutions from more advanced races. Everything we've achieved we did ourselves. Every scientific discovery, every technical invention, Every symphony and every painting, all of this is the fruit of our mind, our labor, our stubbornness. Light years are not only a prison, they're also a cradle, a protective barrier, space for maturing without interference from older siblings. Maybe the universe knows what it's doing? Maybe distances are needed precisely for this, so each civilization matures independently, understands itself, achieves wisdom before meeting others? Or it's just chance? Physics has no intentions. Laws of nature don't pursue goals. Constants are what they are, not because someone designed it that way, but because that's how reality is structured. Whatever the reason, the result is the same. We're here, alone, with all our potential, with all our limitations. The question is, what will we do with this? I sometimes think about those first astronomers of the 19th and 20th centuries, about those who first measured real distances to stars and galaxies. What did they feel realizing the true scale of the cosmos? Probably some experienced elation, intoxication from boundless possibilities, awe before the great unknown. Others, perhaps, felt that very cosmic horror we talked about, realization of their own insignificance, fear before the abyss that stares back. And still others, maybe, just shrugged and returned to calculations. For a true scientist, the universe is an object of study, not a reason for existential crisis. And you know what? All these reactions are correct. All of them are part of human experience. Because the universe doesn't dictate how we should relate to it. It simply is. And meaning is what we ourselves put into it. You can look at light years and see an insurmountable wall, a sentence to eternal isolation, the end of all hopes. Or you can look at them and see a challenge, a riddle that perhaps your distant descendants will solve, a horizon worth striving toward, even if you know you won't reach it yourself. Or you can see beauty, incredible, overwhelming, sublime beauty of scales surpassing any imagination. All of this is truth, simultaneously, and in this multifacetedness, freedom. The freedom to choose your attitude toward your own place in the cosmos. I often reflect on humanity's future. What will become of us in 100 years? In 1,000? In 1,000,000? We can destroy ourselves. This is a real scenario that can't be dismissed. Nuclear winter, climate apocalypse, a pandemic of a new type, AI gone out of control. There are enough threats. We can stagnate, reach a certain technological plateau and get stuck on it for millennia. Exist on one planet, not moving further. Like some biological species that found their niche and stopped evolving. We can spread out, first throughout the solar system, then, who knows, maybe to the stars? Slowly, painfully slowly, over millennia, but move forward, expanding the boundaries of the habitable world. Or we can transform into something completely different, integrate with technologies, upload consciousness into a digital environment, become something our ancestors wouldn't recognize as human. I don't know which path we'll choose. Nobody knows. The future is an infinite tree of forks, and each of our decisions is a branching point. But I know one thing for certain. Whatever happens, light years won't go anywhere. They'll forever remain there, drawing the line between dream and reality, showing us the true size of our sandbox. Imagine that one day we become almost omnipotent, learn to defeat death, gain power over matter at the quantum level, transform into technological titans. So what? The speed of light will still remain an impenetrable ceiling. This limit is hardwired into the very structure of reality. It can't be fooled by any engineering tricks. And in this, strangely enough, there's something reassuring. It means we're not all-powerful. It means there are laws above us, something that will forever remain beyond our control. The universe keeps us in check, doesn't let us imagine ourselves masters of reality. No matter how many technologies we invent, light years will stand guard. Silent sentries at the borders of the possible. And you know what I think? There's a beauty in this. We don't need to conquer galaxies. Don't have to storm infinity. We can simply be on this wet ball flying around an unremarkable star. The universe doesn't care about our ambitions. It doesn't expect feats from us. It doesn't even suspect our existence. We're free to write our history as we want. And perhaps the main wisdom that light years whisper to us is precisely this. You don't have to storm the impossible. Don't have to reach for stars that are forever beyond the horizon. You can simply live your life. Consciously. Fully. With an open heart. See the stars in the night and accept their unreachability. Find peace in this acceptance. This is not defeat. This is maturity. The realization that not all boundaries need to be stormed. Not all mysteries require solutions. Sometimes it's enough to simply stand on the shore of the ocean and watch the waves. Stars blazed long before your ancestors descended from the trees. They will blaze when not even myths remain of humanity. Your existence is a lightning flash against the backdrop of eternity, a spark of intelligence in the boundless ocean of non-being. And this spark is priceless precisely because of its ephemerality, precisely because of its incredible rarity. Think for a moment, how many particles of matter will never become part of something living? How many suns will never warm a world where someone asks, why? How much space will remain eternally empty, cold, unnoticed? And you're here, breathing, thinking, feeling the texture of reality. This is a victory against monstrous odds. A jackpot in the cosmic lottery where almost all tickets are blank. Don't waste this miracle on sadness about inaccessible horizons. Don't burn it in longing for the impossible. Absorb what is right now. Treasure each moment. Be present, because only now possesses reality. The past is a collection of memories in neural networks. The future is a fog of probabilities. Only this moment is alive, hot, real. This moment unfolds here, on the third planet from a yellow dwarf, under a dome of sky studded with unreachable beacons, in the company of beings who also raised their eyes to the heavens and asked, "What's there?" We're all sailing on one ship, 8 billion souls, divided by thousands of languages, beliefs, traditions, but connected by one sky, one fragile planet, one unpredictable fate. And if anything can overcome the abyss of light years, it's the understanding of our unity. The realization that we're all the crew of one ship, drifting in infinite night. Maybe this is the real discovery? Not in equations of space curvature, not in blueprints for photon engines, but in elementary humanity toward one another. We're too insignificant to war among ourselves, too vulnerable to waste precious time on enmity, too isolated in space to reject those rare beings who found themselves nearby. Light years demonstrate the depth of our loneliness. And in this loneliness we must see not a reason for despair, but a call to hold together. Because only each other can we embrace. Only with each other can we share thoughts without a delay of decades. Only with each other can we share silence. This is a privilege denied to civilizations separated by the abyss. This is a small miracle we don't notice. When you embrace a person, you're performing an action physically impossible with an intelligence from the Alpha Centauri system. When you converse with a friend, you're enjoying an instant exchange of ideas that cannot overcome interstellar distances. When you sit silently next to someone close, you're throwing a bridge across a distance that's insurmountable even for light. Closeness is our antidote to cosmic cold, our way to light a fire in the icy desert of the universe. Don't forget this gift. Now let's return to the beginning of our journey, to the star-studded sky. When it gets dark, go outside. If possible, escape beyond the light pollution of the city. Find a place where the darkness is real. Lie down on grass or sand. Direct your gaze into the abyss overhead. Wait until your pupils dilate and adapt. 15 to 20 minutes. Slowly, faint stars will begin to emerge from the blackness. The Milky Way will materialize as a ghostly glowing road cutting the sky in half. Be aware of what you see. Each glowing grain is a thermonuclear furnace. Some are colossal, hundreds of times more massive than the sun. Others are modest red dwarfs smoldering with barely visible light. Some were just born, they're only some millions of years old. Others are billions of years older than our planet. The photons now touching your retina have been flying through the void for years. Sometimes decades. Sometimes centuries. What you see is not real time. This is archaeology of light, the past preserved in particles. And you are an integral part of this spectacle. You are the coordinate from which the cosmos observes itself. You are the node where matter realizes its existence. This is an incredible honor. This is a burden. This is a gift beyond price. Yes, we cannot overcome light years, cannot physically reach those suns upon which our gaze is fixed. We're chained to this rocky ball. But we're capable of comprehending, capable of marveling, capable of feeling connection. And you know, maybe that's more than enough? Maybe the purpose of intelligent existence isn't to colonize every corner? Isn't to plant flags on all worlds? Isn't the conquest of infinity by force? Maybe the true purpose is in the act of awareness? In the fact that for a brief flash of cosmic time the universe could know itself? Look at its reflection through the eyes of a thinking being? Ask itself a question about its own nature? We are this moment of illumination. We are this look in the mirror. We are this thought about itself. When we disappear, and disappearance is inevitable, the cosmos will go blind again. It will expand, cool, evolve. But without observers, without understanding, without any meaning. But right now we exist. Now we see. Now we are aware. Guard this as the greatest treasure. Keep it in your heart. Carry it through your life. For this is the most precious substance in all creation. Not supernovae, not quasars, not colliding galaxies, but this fragile flicker of awareness burning on a lost grain of sand in an ocean of darkness. You are this fire, and while it hasn't gone out, there is light in the universe. Good night. May the stars accompany you into sleep. May the abysses between them teach you to value closeness. May the boundless indifferent cosmos bring you not horror, but peace. For you are home, at the only home in the universe, under a sky where distances are measured in the impossible. And this is perfect. Close your eyes. Feel your breath. Let go. The universe is patient. It will wait.